program to solve the problem. And finally, we should get the optimization result from it. And again, we see that k equals to 1, which is larger than 0, which means that the solution process is successful. And these are all the results we finally obtain for this particular example. And this is the final objective function. Now let's consider a more complicated problem. We have multiple indexes.
What is the difference between the X capital M,
which is lower boundary and upper boundary? In mathematical form, we have We have this one as a constant. So the lower boundary and the upper boundary. If there isn't any boundary, we can assign it either to the empty matrix or to minus INS minus INS as for lower bounds and INS for upper bounds. Now let's consider a more complicated problem. Here we have a double subscript for x. So how can we solve this kind of problems? Because in Matlab, what we need is an x vector rather than a matrix. So what we have to do is to introduce a new set of arguments. x1, for instance, we set it to x double 1, x2 to x1, 2. And finally we can set all the variables in a vector. Like this, we have to select, to rearrange the variables into a single subscript vector like this. And then we can rewrite the original problem like this. And finally, we can solve it. So it seems that there are limitations in Matlab in solving this kind of problems. There isn't any standard program to convert it. We have to do that by hand. So this is the solution to this kind of problem. And finally, we should write F vector A, B, and the lower bound, and then we can call improv command to find the final solution to it. And after the solution, we have to transfer the result back to the original variables. For instance, if we find x1, then as a result, we should use a manual method to assign it to x7. So this is the solution to such a kind of multi-subscript problems. We have to rearrange the problem first, and then we have to solve it in a standard way. And then we should substitute the result back. Now let's consider another special form of constraint problems.
And we didn't get any of the sample. What was it? A.
Sorry, it was the
A to EQ matrix, or B to EQ.
in this example, I do not have it.
So what would it be?
You can also write out a matrix form like this. Suppose we change. Suppose we change this one to an equal to 0 function. Then we can extract A and B from this one, and extract A equal and B equal from this one.
Oh, equal, okay.
Equal, okay. So you can get all the matrices.
In this case, this example, we have to find the maximum, right? And say we need to multiply by minus 1, and then the final result is going to be,
oh yeah, that's true. The final result should be the minimized one. And should be minus, you have to multiply minus 1 back into it. Yeah, that's true. Thank you. Because you have changed the problem. Yeah. But the solution is the same, but the objective function is different. So you have to multiply it back.